The formal limit definition. A lot of people see this equation and do not know what the hell it means. In algebra, this is actually the difference quotient. In calculus, a little bit different. This is actually the derivative, and using this equation, we could find the slope of a line tangent to a curve at a point, right? So suppose we're given this function negative x squared plus 4, and we want to find the derivative of that function, right? The first thing I'm going to do is find f of x plus h. We know what our h is. We know what our f of x is, right? This is just f of x, which is a function. We do not know what f of x plus h is. We know what h is, right? The limit is going to be approaching 0. So this is the only thing we do not know what it is. So that's the first thing I'm going to find. So f of x plus h is going to be, well, I'm going to plug anywhere I have an x in this function, I'm going to plug x plus h in. So negative x plus h squared, all right, plus 4. Distributing this, right, I'm going to have my negative on the outside. This is just x plus h 2 times. So this is x plus h times x plus h plus 4. Now I'm going to multiply to get what really x plus h is. All right. You got to factor it out completely. So this is minus on the outside. X times x is just x squared. All right. X times h is just plus xh. H times x now is just same thing, plus xh, and this h times h is just h squared plus h squared, right, plus 4. All right, so I'm going to distribute this negative all into this thingy, because this negative is very important. So f of x plus h is now going to be equal to negative x squared minus 2xh, because remember, we have 2xh's here, so I just combine them in one step. And then this is just minus h squared plus 4. So this is what f of x plus h really is. So now that I have that, I could just go in and plug it in my formula. So f prime of x is equal to the limit as h approaches 0 of negative x squared minus 2xh minus h squared plus 4, all right, minus my whole function f of x, which is this right here, right? So I'm going to put a big bracket there because I want to make sure I distribute this negative sign here. So this is negative x squared plus 4, and this is all divided by h. All right, so now we just got to do a little bit of arithmetic. So f prime of x is equal to the limit as h approaches 0 of negative x squared minus 2xh minus h squared plus 4. Now I'm going to distribute this negative inside here. That's why I put my parentheses. So this will be plus x squared minus 4, all divided by h. All right, so f prime of x is now equal to the limit as h approaches 0. Sorry, you guys couldn't see that. Limit as h approaches 0 of, well, looking at the top, I see that I have a plus x squared and a minus x squared. So these cancel. I also see that I have a plus 4, and a minus 4. So those cancel. So on the top, I'm just left with negative 2xh minus h squared, all divided by h. All right. F prime of x is now equal to the limit as h approaches 0. Well, we could factor out an h here, you see, on the top. So this now becomes h on the outside, negative 2x minus h, all right? They both have an h in common, all divided by h. All right, this allows me to cancel my h's. And so f prime of x, all right, is now equal to the limit as h approaches 0 of negative 2x minus h. All right. Well, at this point, we could just go ahead and plug in 0 in for h. And so f prime of x is really equal to negative 2x because h is just 0, right? So that is our derivative using the formal limit definition.